Hello all, and welcome to another video from Ellensburg Amplifier Repair and Service. Today I'm just gonna bring you along on a repair here. I'm just doing a repair on a Taramps DS800x4, so I just figured I'd just fire up the camera here and just show you guys, or you guys can watch what I do and how I do this. So sit back and enjoy. I had already started tearing down this amplifier before, of course, I decided to turn the cameras on. I'm like, oh, you know, we better get some content going, right? All you guys love content, I hope. But yeah, I just like to keep this channel rolling. I do thank everyone for subscribing and watching and supporting this channel. There's a severe need for people that are willing and able to repair electronics. Why is it so dark? It's because I have more light above me now. Hold on, guys. Studio lighting, is that what people call it? Studio lighting? I have no idea what it's called, but lighting in general makes taking videos realistically difficult. So yeah, again, I will state I am no pro with videos or recording equipment. I'm no pro in anything. I don't know, people think I'm a pro at repairing amps. I'm not a pro at repairing amps. I just understand the topology of the amplifier to know what's right and what's wrong. And for this amp, what we have here is we have a shorted output channel, which is common on these multi-channel boards. During the diagnosis, I found this channel to be shorted, which is why the transistors are cut out of circuit. Why do I cut them out of circuit when I'm diagnosing amps? It's to check to make sure the rest of the amp is still alive. So what I do is I cut out the shorted transistors. Where's the holes? There it is. I cut out the shorted transistors, and then what I do is I pulse the remote circuit to make sure that the amplifier in general works as it should. Does this one does not use an MCU. No, this amplifier is not smart in any way, shape, or form. Yep, it's just a remote circuit. Turns on the IC that drives the power supply. The power supply had already opened for me nicely, so I was able to pulse to make sure that, you know, everything else is still functional. But for a failed power supply, you have to end up replacing the transistors, checking your gate resistors, replacing the gate resistors as needed, replacing the drive IC right here, and and the 10 ohm resistor. Sometimes right here that powers the IC. That it doesn't power, that allows voltage to power this IC. That's it for the power supply. You couldn't get any more simplistic than this, and I love it. I love working on these. I can have these in and out done. Oh, I can have one of these repaired in about 30 minutes. So as long as when the output fails, it doesn't take out the 2093 IC. These are a bear. If you're not used to soldering these what are these, QSOP? I don't know. I'm not up on, you know, all the different words for ICs, but if you're not familiar with soldering these 2093s, I highly recommend using practice boards that have cooked. I highly recommend to go into other ICs of this style to start to practice, because you will need practice on these. And I say that so you don't burn up the IC trying to put them in place. So let's get this thing fixed. Just firing up the Hacko. You 301 here. 301 is my ultimate all-around go-to tool. I'm just assessing what I need to remove here real quick. So what I'm going to remove is the shorted output channel, all the power supply transistors, removing the gate drive IC, and of course, going from there. So I will be quiet and I will get to work. Got my new Hacko tips in. I tell you what, business ceases. I mean, not 100%. I mean, I have other things I can do. Without a desoldering gun, I'm telling you right now, if you do this as a business, you lose it. If you burn your tip up and you have no extra tips, you're pretty much dead in the water. If time is of value to you. But thank goodness I got new tips in. The new tips do come with lead-free solder already on the tip, so let me turn this down just a hair. It seems like I'm a little high. 1.5, 1.5. I'm going to bring it down just a little bit. All right, let's get these things out of here. Really simple. Really simple. I'm going to try to keep all this stuff in frame here, of course, for you guys. It was so funny. I had someone leave me a comment on a video about my sound. So hopefully my sound is a little higher for you guys today. It doesn't. I'm not going in the red, so I'm assuming I'm okay on sound. I did turn it up a little bit. But you know, guys, it's like I pinned the guy's comment. We have choices. If you don't want to watch my channel, if you don't like my channel, don't watch my channel. It's pretty simple. I mean, we live in a country of nothing but free choice. Well, for the most part. So if you don't like it, don't watch. But I guarantee you, I'll be able to teach you something. But that's what I've done my whole life, is teach people. So what I'm doing right now is I'm just pulling out the legs of the output transistors. Should I cut the transistors? I shall. If you want to save any headaches, the easiest thing to do is to cut your transistors out, leave the leg behind, so you can use your tweezers to pull each individual leg out. Instead of fighting to free up 3 legs to pull your transistor out, just cut your transistors out and just pull each individual leg right on out of here. It's pretty simple, pretty simple. Oh, I couldn't tell you how much I love new desoldering tips. Works like a champ every time. Never fails. So a little tip on desoldering tools. Besides, you know, keeping them clean, which I do have videos on about keeping these things clean, is the desoldering tip itself has a coating on it that if you scrape the coating off or whatnot, or leave your iron on overnight, which I've done a few times, that coating that's on the tip, if you scrape it off, that tip will literally melt itself, and then your tip is done. Throw the tip away. So every time I'm done soldering transistors, I always turn this thing off to preserve the tip itself. This is the long tip. The long tip works better than the short tip, in my opinion. It's just that easy to pull transistors out of a board. you got to find a way that's quick for you, efficient, for the times when you get something like 10K, 15K, or a 17K board in where you got to desolder 50 some odd TO247 transistors. Guarantee you've said a few words in the past when trying to pull those transistors out in one sitting. So I just find ways that makes the job easier for me. And the Hakko FR301 is the easiest way. Or the 808 if you have an 808. The 808 though is the 808 is beast. I use the 808 on the Taramps 30Ks to split the boards. For y'all that work on the Taramp 30Ks, you'll know what I mean when it comes to splitting the boards. Don't work on the 30K in one unit. Just, I would avoid it. You're gonna end up popping traces because of the length, and they flex so much. Pull the board in half. Okay, so now I need to check my gate resistors. First things first on any amplifier is you gotta get a power supply going. Your amplifier is 100% worthless without a power supply. So if you cannot get a power supply running, the rebuild of the amp is pointless. All the gate resistors are fine, 3.8 ohms. Let me bust out my trusty magnifying glass just to double check and verify that I do not have any holes in the tops of these bad boys. If I can locate, give me 2 seconds, guys. No hole, no hole, no hole, not even hot, which is good, No holes in the gate resistors. Hold on. The drain was literally burnt in half, which doesn't surprise me. No holes in the gate resistors, so that means the short did not manage to go from drain to source, or not drain to source, drain to gate, which means most likely, hold on, the drive IC is not going to have any issues because it did not burn up any gate resistors. And the 10 ohm resistor is still intact. 9 times out of 10, when you lose one of the power supplies in these things, you will lose the 10 ohm resistor and you will lose the drive IC. It's just a given. But no damaged gate resistors. So that's promising. I'm just gonna put some power to this bad boy. Like my remote. Here's my remote. Yep, that's all I do, guys. Just an alligator clip. I mean, there's no need to make things complicated. 12 volts. It's actually like 12.6, I think. 12.6 on the nose. Yeah, just a 12 volt. It's just a brick. Plug in the wall down below. Plug it in the wall. Put some alligator clips on the bad boy, and I can fire up almost any amplifier with this. It's a 10 amp plug in the wall power supply, and I can test any amp with this. It's hard. There is one amp that I want to say one design that is kind of hard to start with this, and that is the Sundown SFBs, or any design that uses that same topology. Yeah, this just you gotta pulse the remote about 8 or so times to build up enough rail voltage on those SFBs for the MCU to say, hey, let's get going. That's the only amps that I found that does not start on the first try, I should say. Most all the other Korean boards, you can fire up any Korean board with this. All right, so what was I doing? Oh, I was checking gate drive. So I'm just gonna put my probe right there, and I'm just gonna click this. Maybe if I can find myself a decent Oh yeah, there we go. We have gate pulse. All right. Yep. Yep, just as I figured. Yep. So on the this holds true for any board that's uh, PIC or MCU based or not MCU based. How do I say this? This works for boards that have programmable ICs and non-programmable ICs. There we go. I try to always word things in a way that most everyone will understand. If I say MCU, some people will scratch their heads, or if I say PIC, some will scratch their heads. Uh, PIC is a type of programmable chip. MCU, you have the F16. I mean, they go on and on. But this board does not use a programmable IC. So I can pulse the remote and see that on my scope for every half section of the transformer. There it is. So, and then of course the pulse goes away because it does is there's no rail voltage. So it goes into protect, more or less. So looks good. We have our pulse. And you can do the same thing on any of the Brazilian boards. You can pulse the remote to check your power supply drive. If you don't have drive, don't worry about anything else. Worry about getting that drive going. If you do have an MCU based board and you lose your power supply and you have a bunch of burn up gate resistors, first thing you always check is the MCU output. Disconnect everything, make sure there's no shorts across your leads, pulse the remote, and see if you have that gate drive coming from the MCU. If you don't, your MCU is shorted. Try not to digress too much, but I have gate drive, which is a good thing. So we have gate drive. Now these are labeled to take the 180Ns, but they have the 1404s in there. This is not a warranty repair. This is a private repair. So I despise when I see that. They're using the 4.7 ohm gate resistors. Let me see my revisions here for Taramps. Yeah, so the 180Ns use the 4.7s and the 1404s typically use the 10 ohm. Let me look through some other revisions here real quick. Yup, 10 to 4.7. And so I'm going to go ahead and put some 180Ns in this. Feel it in my hand. If I can find them. Hold on, guys. Let me locate my transistors. All right. Whew, getting a little thin on the 180Ns here. 1, 2, 3, 4. Let's see here. This is an unedited. Well, I mean, I'm not going to do much editing. This probably will most likely be an unedited video, just to save on time. I mean, I'm not extremely busy this time of year, but if I get slacking too much, I will fall behind, and I don't like to fall behind. Customer satisfaction, on top of quality, are the two key aspects of this business. What we call those core values. Turnaround time and quality of repair are the two top key values of Ellensburg amplifier repair and service. And then one day when I have employees, employee relation is going to be a core value also. But I don't have employees, so it's not a core value right now. As you all know, well, as most of you know, I use the 301 for almost everything. I use it for soldering, desoldering. It's my all-around go-to tool. So I use a different tip when I'm doing just soldering. Why? To save the one, I use 1.3 millimeter pretty exclusively. They're $20 each. From Hacko, I buy from Hacko. I'm tired of the cheap Chinese garbage that's out there. I buy my tips straight from Hacko, and they're $20 each. So, and I buy them in twos. Always have a backup. Yeah. $20 each for the Hacko FR301 tips. Between $16 and $20 is the average cost for them. So I try to preserve them as much as possible because I do solder. Oh, I couldn't even tell you how many transistors I solder in a month. Again, what I do is I solder one leg in place. I do the source because it's got the most surface area. I try not to do this with the gate side so I don't get the gate or the transistor too hot or internally too hot. So I like to use the source. I mean, you can do the drain too, but I like to use the source. Just like that. I solder each transistor, one leg, only one leg, because you got to adjust them to make sure they're straight, level, where you want them, how you want them. The more bending you do on them, the more stress you're going to give those legs and potential for a warranty return. And anyone that runs a business knows if you get a warranty return, all it does is it eats into your company profits. Capacitors are still charged, and it slows down the repairs. Gosh darn it, capacitors are charged. It slows down the repairs for your other customers. So for those customers that ask me, I get funny emails. I'll get customers that ask me, can you test the amp before you send it back? What are you talking about? Who doesn't test an amp before it goes back? Oh, yeah, I just, like, what? Are you kidding me right now? Of course I'm going to test your amplifier if it goes back. No amplifier goes back unless it's tested. If it doesn't work here, it's not going to work in your vehicle. So I just think that's kind of funny when people ask me those kind of questions. Soldered in place. And then while I'm here, I'd like to run my finger across the backside of the transistor to get rid of any of the flux that has made its way to the face of the transistor here. Face, back, not sure. You don't want to get those little blobs or balls of flux stuck in between your insulator and your heatsink. So, all right, there's that power supply. It's back together. What do we got here? We have the IRF 530Ns. I need two 530Ns, and we're gonna cross our fingers that this thing fires up. 530N. Oh, the question is, where are my 530Ns? have a tray for 530 ends. Taramps says. Hold on, guys. Hold on. I gotta look at one more tray here. Of course, it's on the bottom. Of course, it's on the bottom. 540s. Yeah. I gotta get on my hands and knees. My 530 ends are down below. I'll be right back. Ah, 530 ends. Oh my gosh, I have beepers and buzzers going off everywhere. That beeper was my coffee. There's one thing you can't live without. I'm sure people will beg to differ, but I can't live without my coffee. All right, let me get these transistors in place. These are the IRF 530 ends. If you don't know what transistor goes here, it's printed on the board. And no, I don't have any substitutions for the 530 ends. I mean, could you use a 540 end? I'm not sure. I'd have to look at data sheets. Not my job to engineer boards. I don't get paid to engineer or re-engineer an engineer's job. So, excuse the noise that's going to be coming our way. Same deal. Soldering the source. Oh, that camera. Beautiful. Gorgeous. And now what do you do when you're all done soldering? Or what is it people don't do? A lot of people don't clean up their flux. It takes 2 seconds to clean up flux. Let's make our job pretty. Pretty? Sorry, English is tough. It's only getting tougher that I've noticed with today's kids. It's gotten so tough they're using their own language. All right. Of course, some isopropyl alcohol to finish up the flux job here. And the trusty Q-tip. Time 30 minutes on the nose. All right, 30 minutes. Hey, not bad. Repair even on while recording. 30 minutes. Whew, not bad. I'm going to set everything. I'm going to set everything to full. Gains are going to be all the way down because I don't really want any gain right now. And here we go again. Make sure your alligator clips are not touching your speaker leads. From here, From here, what do? Before you apply power, and let's say you just put in fresh new transistors, what's the next thing you need in your toolbox? That's right, the imager. All right, because what I'm going to do is I'm going to double check and make sure that the output transistors are not gonna heat up on me. These are a little warm still because I just put heat into them, but can you see? Oh yes. Oh yeah, look at this. Oh there. Right there. Oh, there they are. That's a thermal imager, guys. And if you were to hit the remote and those were to turn red hot, you know, at least on your screen turn red, then you know you have a problem. But that's what I'm looking for. I'm just waiting for things to cool down for a second here. Turn on some power. Power supply transistors are just fine. Of course, that's what I figured. Nothing else is hot. I get a blue light that comes on. Let's check our output transistors. I get a blue light, so that means we get rail voltage. Nice. Nothing. Nice. No heat. Sorry guys, I'm this way, you guys are this way. Not a single transistor heated up. That's what I was looking for. If you had a problem, your transistor would heat up practically instantly. And with the thermal imager, it'll allow you to see that transistor, or at least see the board. And if anything heats up real quick, you just pull the remote to cut power. Because I guarantee you that transistor that's heating up, red hot, will drain your rail voltage before it blows up and blows everything else up. It'll just drain your rail voltage. So the quicker you remove the remote, as soon as you see something heating up, the better off you are. So no heating output transistors. The next thing is we may have no heat because we may not have any drive. So we're going to check the drive. Just because you have no heat doesn't mean you don't have any drive. And we have drive. Hallelujah. Look at that. Beautiful drive. Beautiful drive. All right. That's exactly what I was looking for. Power off. Do a manual. I'm just doing a manual check, even though the thermal imager is, I mean, the imager will never lie to you. Neither will your fingers. But sometimes these things will get so hot, and if you're not expecting it, you will burn your finger. I don't know how many times I've burned a TO220 picture into my thumb. All right. Good to go. Heat sink. Real simple. We're just going to go over the assembly real quick here. Heat sink. What I do is I always inspect the thermal compound. There's a state a thermal compound should be in, and there's a state thermal compound shouldn't be in. Thermal compound should never be dry. It should never be crumbly. It should be just like a normal oily thermal compound. And if it's not, replace the thermal compound. But this compound here, I am able to spread out nice and even. It's not dirty. It is completely clean. So I'm going to respread this compound right on over the insulators. Just like that. So my camera, yeah, blah, blah. You get the idea. Then we're just gonna, oh, hold on, remember, I never install boards if there could be a potential of rail voltage being present. Yeah. Oh, this is a giant 2 ohm resistor. Not giant. It's hanging here. It's a 225 watt ceramic wire wound resistor, big resistor, which I used to use as a load to test small amplifiers as I was starting this business. Small. Keyword was small. Bam, just like that. All right. 2 screwdrivers that you use almost all the time is a T10 and what's the other one? A T11? Or these aren't even labeled? Oh my gosh. Garbage. Hey, lifetime warranty. Uh, yeah. T10 is something you're going to use all the time on Brazilian boards. So we just screw this thing back together. But that's how I do it. I replace the parts, check for drive, check for heat. Then I reassemble. I may speed up the video through some of this boring stuff. And guys, don't over tighten your screws. Don't cross thread your screws. These Brazilian heat sinks, as soon as you cross thread them, they're done. I mean, you strip it out, and there are tricks that you can do to make them work again, but these holes are super easy to strip out, so don't strip them out. Make sure your insulators are completely protecting the bottom side of that transistor, and make sure that that mica, the hole in the mica, is nowhere near the bottom side of that transistor. It will, I'm not so sure about this one. I don't think the voltage is high enough. But on other amps, the back side of that transistor, if your mica is kind of underneath, the hole of the mica is underneath the backside of that transistor, it'll arc from the backside of that transistor right to the heatsink using the screw. So that's a lot of the common OEM failures that I see is get the mica misaligned and it's done for. And you can kind of see it right here. I lay the tie down. I call these tie downs, guys. If I say tie downs in my texts or emails to you, that's what I'm talking about. You're tying the transistor down with these. When I remove tie downs from a board, I always lay them out in order that they came out from. Trust me, you will thank me for doing that. Your boards will go back together so much easier if you just put the same tie down in the same location. I shouldn't say the tie down, the same screw. As long as the same screw goes in the same location, your tie downs will go down much easier. Raise your hands for anyone that's dealt with 30Ks. Yeah, that's why I don't do private repair on the 30K Taramps. I do warranty repair, obviously, because, you know, I do warranty repair for Taramps, but I will not take a base 30K in for private repair, guys. Sorry. I'm not comfortable charging the prices that I have to charge to service them. I'm a tech with a heart. But yeah, if you have a 30K that needs repaired, you might as well expect to pay anywhere from $650 to $1,000 to rebuild that thing. And it just takes a tremendous amount of time. I can't get it done in 2 hours. Which is the reason why I don't take them in. If I can't get your amp done in 2 hours, I will choose to no longer take that model in for service. I have too many customers in line to spend, 2 days on an amplifier. Just can't do it. Why don't you get employees, Todd? Well, yeah, not quite at that point for me to have employees because one, I work out of my home. For all you guys that have looked into leases for buildings, and for the guys that don't like to borrow money, I can't stand borrowing money. I can't stand paying banks to borrow money. I know sometimes it's inevitable, it happens. I mean, we buy cars and we buy houses. Those are two items in my life that I will accept paying interest on. Uh, Otherwise, I just despise it. Yeah. All right, that's in. That's in. So what I'm going to do now is I'm just going to double check and make sure that all my insulators are free and clear. This is one time I will use the beat mode. Why? Because it's quick. Because it's quick. What I'm doing is I'm just making sure the drain of most, unless it's a full F on the part number of your TO220 or any transistor, um, the backside of your transistor is exposed and it's the drain. So what I do is I just take my 1 meter lead, go to ground, and just make sure none of your drains are grounded. You will find that somewhere along the line here, you'll have uh, one side of your power supply to ground. Don't get that confused. We're looking at the drain, the center tab of that transistor. And this is beeping because it's trying to charge the rail capacitors. There. But I don't have any shorts. There's the rail capacitor charging. So, no shorts. That's it. This is going to go back together and go on the test bench because we already proved that there is drive. Oh, I'm going to show you one more thing. One more thing, guys. Gorilla Glue clear grip on these RCA jacks on these Brazilian boards. I will take some and I'll squirt it right underneath that RCA jack. Because how many times have you got an amp in where your RCA jack pins were broke off the board? Yeah. Glue them in place there, guys. Do the customer a favor. Take the 2 seconds, squirt some glue in there. Customer satisfaction. And then just screw everything back together. You're going to hear the furnace kick on and off there a few times during this extremely abnormally cold weather that we've been having. Every winter, I tell you guys, it might get a little noisy in the background here. And yeah, even on the RCA screws, don't over tighten them, guys. You'll strip that RCA screw right out of there. Last but not least, last screw. Oh, hold on. This amp is missing the 4 M's. These are M4s, by the way. Terminal screws. M4. Speaker. Terminal screws. I have like 1,000 of them. Done. There it is, guys. Taramps. Upside down. Taramps. DS. 800x4. Done. Complete. New screws are installed. Power supply transistors. Oh, hey, look. There you go, guys. You can see what I charge those. Output channel repaired. The Class D IC survived. There was gate drive, so that's okay. 9 times out of 10, when that's fine, there's no preamp issues, so I'm not worried about checking for signal at this bench. So yeah, this is ready for testing. So I do thank you guys for watching. If you got any questions, leave them down below, and I'll get to you as soon as I can. Please like and subscribe if you like this kind of content. It does help support me and get more videos out to you guys. Thanks for watching. We'll see you next time.